Algebra 2, Lesson 19, Value Word Problems, and angle angle means angle angle angle. So beginning with value word problems, we'll be starting on practice A. They tell us Florence had 80 nickels and dimes whose value was $6.50. How many of each coin did she have? So the key to value word problems is we need to write two sets of equations, one involved with the number of the items, and then one involved with the value of the items. So we need to remember we have 80 nickels and dimes and the value is $6.50. So I've got 80 nickels, dimes, and then $6.50 is the value. Okay, now the way that we're going to make two equations is we're going to use subscripts. We're going to refer to nickels as number of nickels, and then we're going to refer to dimes as number of dimes. And what this first bit of information tells us is that there's 80 total. So if we were to count the number of coins, we'd have 80. So in other words, if we add up the number of nickels with the number of dimes, we would have 80 coins. Now, to create the value equation, so the first equation is really simple. We just add up the number of each item and write down the total number of items. The second equation is almost the exact same thing, except we apply a value. So we're going to take the value of a nickel in decimal form, which is 0.05. Right? Nickel is 5 cents, 0.05. We multiply the value times the number of nickels. We add that to the value of dimes, which is 0.1 or 0.10 times the number of dimes. So now that we've added value to the equation, the total amount isn't going to be the number of nickels, but the value of those items, $6.50. Now, before I start working, I like to convert these decimal equations into whole numbers. So the biggest decimal I have goes to the hundredths place. If I multiply every value in this equation by 100, I would get an equation with whole numbers that looks like this. So this way I don't really have to worry about decimals, and I can go ahead and solve using whole numbers. So I've got my two systems of equations here, and I can start substituting and eliminating in between them to solve. I'm not going to go ahead and go through that, because the main thing we need to take away from these equations is how to create this point, how to get to here. Once you're here, you can choose to substitute or eliminate to solve the problem. So let's go to example B, and we'll go through this exercise one more time. It says roses sold for 12 pence each and daffodils for 4 pence each. Jim bought 35 flowers and spent 300 pence. How many daffodils did he buy? Okay. Now, what they do in this one is they give us a rate or a value of each flower. In this case, the value of roses is 12 pence, or the cost of a single rose. The value of daffodils is 4 pence, or the cost of a single daffodil. So we can work with foreign ideas like pence and flowers, as long as we know what the value of each is. Because, I mean, we're not in the UK. We don't deal with pence or pounds or euros or anything like that. So we don't have to know what a pence is or a pound, as long as we know that one rose costs 12 pence. We've got a value. We can solve this equation. So again, we're going to focus on the total number, 35 flowers being the total number, and then the total value being 300 pence. So let's use that to start writing our equations. So I'm going to come over here to my work page, and I'm just going to put down those notes, which is that there are 35 roses and daffodils. The total cost was 300p for the value. And then I'm also going to put some notes as far as the cost for a single item. So 1R cost 12 pence. And then 1 daffodil cost 4 pence. So now I can go ahead and start writing my equations. So I'm going to start with the total value equation, which is number of roses plus number of daffodils is going to equal 35 flowers total. All right, then from here I'm just going to take the same equation and I'm going to add the value. So the value for a rose is 12 pence. So I take 12, I multiply it by n sub r, and then I add that to the value of daffodils, which is 4. 4 times number of daffodils. And then that value, the total value, is going to be 300 pence. All right, from here I've got my two systems of equations, and I can use substitution or elimination to solve these problems. So just to be clear, on these problems, we're not done once we get to this point. Once we get to this point, we have to use substitution or elimination to solve for the number of the number of each unknown in each problem. But as far as the newness in these problems, this is the only new thing that we have to deal with. And then lastly, angle means angle. All this is saying is that if we know two angles of a triangle, since every triangle adds up to 180 degrees, and two similar triangles have two angles equal, well then the third angle must also be equal. So if you have angle, then it is impossible to not have angle. So if two triangles share two similar sides, like the first one and the first two that we started with, then third ones are also equal. And then they want us to use a scale factor to solve for the unknowns. In this case, since the triangles are inverted, this one is flipped. 4 would be to y. 4 times a scale factor would equal y. 5 times a scale factor would equal x. And then 3 times a scale factor would equal 5. From here we would just solve for the scale factor, which is equal to 5 over 3. And then we can plug this into each of these to solve. So 4 over 1 times 5 over 3 gives me 20 over 3. That's what y equals. So y equals 20 over 3. And then for x, 5 over 1 times 5 over 3 gives me 25 over 3. So then x is equal to 25 over 3. Problem solved.